Three and two and one. Good evening, family. It's your big brother, Spiritual Awakening, and I'm here to educate ourselves and myself on how to gain a higher consciousness, uh, be it that spiritually, psychologically, emotionally, mentally. Yeah, we're working on getting better. I hope if that's what you are doing, that's what I am doing. I've always been that guy that was always working to be better, stronger, faster. I don't want to be, you know, boastful, but I've always worked on greatness. I've always wanted to be better. Now, because of who I am and where I grew up at, there were these barriers, you know, barriers. The history that we was taught was fake. Um, the information that we're given uh, through different social devices, you know, it's called social engineering. So we were engineered. We were engineered to think a certain way through television, through music, through designer clothing, right? We and fake news. So we were trained to think a certain kind of way. So, you know, outside, because I've been in the shit, I've been in the shit. I was caught up, especially when I was younger. I was caught up in this shit because I was young. I didn't know no better. And at that time, I knew that there was something going on that was against me. I couldn't put my finger on it. I couldn't put my finger on it. I knew something was going on. I knew that there was a machine that was working to keep me under. Whether you believe it or not, that's your problem. I've gained enough information and enough wisdom throughout 50 years of living that certain things I just know. So we're going to do a fair use. First thing, fair use, fair use. This is for educational purposes only. Fair use. Now I want to start off with this article called Time for Change. So right now during this pandemic, man, if you have not figured out that it's time to get right. One sec, wait, let me shut my door. I got family running around the house, kids, and all kind of stuff going on. Wait a minute. All right, excuse me. So, what was I saying? So, during this pandemic, and well, we're in 2021, but in 2020, when the pandemic first started, everybody panicked. Me, I sat back, got into different scriptures to get a perception of what's going on. Um, I've been involved in different ways of living because, like I said, I've always reached or like reached to try to be better, to try to get more information, to try to get, you know, the only thing about that, digging and digging and digging, you might find yourself into a rabbit hole that you're not gonna like. So when I'm digging for more information, when I get to a certain point, for me, I know when to stop because I don't want to be involved in no negative energies. I need my energy, my frequency, and my vibration to be right and intact because even though I am 6 feet, 240 pounds, I got a nice little bench press on me and everything. Right now, at this time period, this war that we're going through, it has nothing to do with the body. Now, I'm talking about as far as combat. Now, you want to keep your body healthy and strong so your mind and your spirit can be strong. But this war that we're going through right now, it's not a physical war. It's a war of the spirits. So you got to get your spirit intact or you're going to be left dangling on the side trying to figure out what happened. So let's get into this. It's time for change. So it says definition of spiritual growth. What is personal spiritual growth? It says there is no official and exact definition of spiritual growth. We and many others use personal spiritual growth as synonyms for other terms like e.g. personal spiritual development, to develop higher awareness or to develop higher consciousness. Now, for me, man, it's almost like my spiritual awakening, my high, my my man, I can't explain it, but it's like these endorphins get released when I'm involved in growing, positively growing, staying out the way, letting Satan have all his little minions do his thing, right? Me, I'm on this because this is what we need. The youngins, they watch us to determine how to live. I noticed that a lot. Youngins watch us a lot. And you can't preach to a youngin about do this, do that, do this, do that if you're not living that way. You got to tighten up. You have got to tighten up. The only way the babies are going to pay attention is you have to be an example. If you're not setting an example for greatness, the kids are not going to listen to you. Period. So let's go into this article. All right. So this is my first time on this page. I'm just checking it out. Right. I'm doing this in real time, so I might be on here for a minute to try to get a couple definitions of what we're doing so you can understand. So this is the awareness sphere, right? It says, without understanding of spirituality, one can also define personal spiritual growth as way to integrate spirituality to a higher and higher degree in our daily life. So, oh yeah, for me, I read slow, especially when it's important stuff. Like if it's important, like um, you know, uh, trying to reach this awareness of growth, I read slow. So let's see what this is. What is this? Our understanding of spirituality. So it says spirituality, spiritual growth for a higher consciousness. With spirituality, we designate our relationship with the spirit world, with the non-incarnated world. The term spirituality has to be understood in a very broad way. It comprises our relation to invisible beings, like, for example, God, angels, spiritual guides, non-incarnated souls, and other non-incarnated beings. Spirituality also comprises questions about the meaning of life and about our personal attitude towards life as a whole and all its related goals and cycles. Right? So it says, before we continue, let's have a look at the definition of spirituality according to Wikipedia. So I guess this is the definition. This is it right here. So it says spirituality is a narrow sense, concerns itself with matters of spirit, the spiritual, involving, as it may, perceived eternal verities regarding humankind's ultimate nature, often contrast with the temporal, with the material, or with the worldly. A sense of connection forms a central defining characteristic of spirituality. Connection to something greater than oneself, which includes an emotional experience of religious awe and reverence. Equally importantly, spirituality relates to matters of sanity and of psychological health. Hmm. So, spirituality relates to matters. So let's see what the definition of matter is. Matter. Matter. So matter, right? Matter is physical substance in general, as distinct from mind and spirit. In physics, that which occupies space and possesses rest mass, especially as distinct from energy. Right? It says an affair or situation under consideration, a topic. A great deal of work was done on this matter. Okay. Be of importance, have significance. It doesn't matter what the guests wear. Of a wound, secret or discharge pus. Matter. So matter is physical substance in general. So matter is what? Something that you can touch. It's physical. Alright? So that's matter. Alright? Some research I was doing. I like learning, man. This is what I do. So it's no telling what I might look up. So here we go again. Let me just throw this out there real quick. So I'm getting ready to, you know, if the Most High allows it, I should be having a little girl soon. And we're thinking about naming her Khalifa. So, what's the definition for Khalifa, caliphate, right? Wikipedia says, maybe I should, let me hit it. Wikipedia says, right, pretty much it's a ruler. Pretty much it's a ruler. It's, it's, um, see, it says Khalifa means king. So it'd be king, queen, ruler. That's pretty much so. And I don't know if you knew that or not, but did you know that? Okay, let me read this one. Calafia or Calafia, right, is the fictional queen of the island of California, first introduced by the 16th century poet Garcia Rodriguez de Montevo in his epic novel of chivalry Las Surgas de Esplandias, The Adventures of Esplandian. So pretty much Khalifa is where California got its name from. And if you want to research who Queen Khalifa was, okay, she was the Queen of California, to where California got its name from. So, yeah, it's more information, but let's get back to what we're talking about. I jump out there, boy. So, so we got a definition of matter, right? It says, equally importantly, spirituality relates to matters of sanity. Matters of sanity. And we know what sanity means, right? Let's look it up just to be safe. Let's look it up. Let's see what they're talking about. Wikipedia, or I like etymology dictionaries, personally. But for the sake of time, we're going to go into, so sanity means the ability to think and behave in a normal or rational manner. Sound mental health, right? I began to doubt my own sanity. So that's what sanity means, right? Just for those who kind of was maybe wondering, right? So, equally importantly, spirituality relates to matters of sanity and of psychological health. So we know what psychological means, right? So y'all know what we're talking about. We're talking about pretty much. Spiritual growth, bringing upon spiritual awareness, right? So that's what we're talking about. We're trying to grow spiritually. We're trying to stay, for me, I'm staying away from all negative energy because to me, for me, um, at this point in my life, no more negativity, man, for me. So I need positive situations. Enough negativity. Negativity also helps us grow. We understand this. But at some point in time, you got to catch it. Or you'll just be starting over and over and over and over and over and over again your whole life. So for me, positive energy, high frequency, no static, period, on my vibration. So if I feel any kind of static, I get away from it. Because I know me. I have a zero tolerance of BS. So do I get caught up in these demons and what they're into? Or do I focus and work on getting better? Which everything starts with, let's see if we can find this. So understand that quantum physics is us. You are quantum physics. Your body is quantum physics. Right? So let's see what Wikipedia says about Wikipedia quantum physics. So it says fair use, educational purposes only, fair use, fair use, fair use. What does quantum mean? Quantum comes from the Latin meaning how much. It refers to the discrete units of matter and energy that are predicted by and observed in quantum physics, even space and time, which appear to be extremely continuous, have the smallest possible values. Hmm. Let's read it all the way out. We're gonna see what the articles are. This is a thought company. So, who developed quantum physics? Come on, man. How we going? Whatever. How you know? It's gonna be somebody that didn't come up with it. There's another thing I've learned from reading and studying. You know, things that people make, things that people come up with. It's not always the author or the original person that came up with it, as they say. It's usually some total different person. For example, Henry Ford, the Fords. Kind of find out it wasn't a Ford. They came up with the whole automobile situation. It was a whole other person. We'll talk about that on another video, but let's stay focused on what we're talking about now. So we're talking about spiritual awakening, right? But right now we're talking about quantum and quantum physics. Spiritual reality. Right now we're talking about quantum physics, right? So let's finish reading this. Who developed quantum physics? As scientists gained as scientists gained the technology to measure with greater precision, strange phenomena was observed. The birth of quantum physics is attributed by Max Planck's. Say attributed. Come on, man. In the 1900s, paper on black body radiation. Ding, 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 ding. Black body. So you already know where we're going, right? And this guy, it was attributed by this guy Max in 1900. But we already know that quantum physics was a situation way before this dude Planck, or whatever his name is, right? But as you see what he did, black body radiation. So you know where they going? They talking about black body. You know what? Let's just see what they got in here for black. I just want to know. I just want to know. I'm just curious. What does Wikipedia have for black body? Alright. So black body, right? So it says black body for the radiation from a black body in thermal equilibrium. See black body radiation. For the Canadian short film, see black bodies. They got a film. Let's see if we can find a video real quick. Maybe there's a video out there we can look at. Well, you got where I'm going. It's melanin, pretty much. So let's go back. Black body radiation. So black body radiation is the thermal electromagnetic radiation within our surrounding within our or surrounding a body in thermodynamic equilibrium with its environment, emitted by black body. It has a specific spectrum of wavelengths inversely related to intensity that depend only on the body's temperature. This looks serious. Black body radiation. Black body radiation. So black body radiation is the thermal electromagnetic radiation. So thermal radiation is electromagnetic radiation generated by the thermal motion of particles in matter. Thermal radiation is generated when heat from the movement of charges in the material is converted to electromagnetic radiation. Mm. Okay. Okay. So electromagnetic radiation. Electromagnetic radiation in physics. What is physics? Physics is the natural science that studies matter, its fundamental constituents, its motion and behavior through space and time, and the related entities of energy and force. Physics is one of the most fundamental scientific, you know, I almost start digging on that because, we, um, we still on the same topic, but I can go on and on and on and on. So let's go black body radiation. Let's come back to black body radiation. So let's not get flustered, right? We're talking about spiritual growth, right? And okay, we're breaking down uh, spirituality, right, which relates to matters of sanity and the psychological health. That brought us to black body radiation. We're talking about black body, right? So black body radiation, right? You got black body, and then we got black body radiation. And I'm not going to open up no more new tabs. We're going to stick on that, and we're going to build on quantum physics a little bit too. Quantum physics, right? So let's go on black body. Black body. For the radiation for a black body is a thermal equilibrium. See, black body radiation, right? For the Canadian short film, black body. We're going to get into that. A black body or black body is an idolized physical body that absorbs all incident electromagnetic radiation. Alright, what is electromagnetic radiation? In physics, electromagnetic radiation, EMR, consists of waves of electromagnetic, which is EM field, propagated through space, carrying electromagnetic radiant energy. It includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. These are different rays. Alright? Alright. Regardless of frequency or angle of incidence. So, a black body or black body is an idolized physical body that absorbs all incident electromagnetic radiation regardless of frequency or angle of incidence. So angle of incidence is what? Angle of incidence is in geometric optics. The angle of incidence is the angle between a ray incident on a surface and the line perpendicular to the surface at the point of incidence, okay, called the normal. The ray can be formed by any wave, acoustic, microwave, X-ray, and so on. Okay, okay. The name Blackbody is given because it absorbs all colors of light. A blackbody also emits blackbody radiation. What? In contrast, a white body is one with a rough surface that reflects all incident rays completely and uniformly in all directions. Okay. Okay. A black body in thermal equilibrium. This is thermal equilibrium. Just real quick, brief. Two physical systems are in thermal equilibrium if there is no net flow of thermal energy between them when they are connected by a path permeable to heat. Thermal equilibrium obeys the zeroth law of thermodynamics. A system is said to be in the thermal equilibrium with itself if the just brief, quick, because I'll be opening up tabs. We would never get done. We're gonna have a part two too. So we're trying to break this whole thing down. Spiritual awakening. Right? We're gonna break this whole thing down. Right? So that is at a constant temperature emits electromagnetic black body radiation. The radiation is emitted according to Planck's law. Well, Planck's law, man. Nobody wrong with no damn Planck's. Planck took it from somebody else. He was the one that was slick enough to steal it and get it patented. I already know. So I'm just trying to get up. I don't like to assume when I'm reading. I like to know, produce and discharge something, especially gas or radiation. Coal-fired power stations continue to emit large quantities of sulfur dioxide. Okay.
What else is going to make your plate?
So we got to understand what that is. So we know what emits means then, right? Alright, so it says the radiation is emitted according to Planck's law, meaning that it has a spectrum the power spectrum of a time series describes the distribution of power into frequency components comprising that signal. According to Fourier analysts, any physical signal can be decomposed into a number of discrete frequencies. or a spectrum of frequencies over a continuous range. Okay, that is determined by the temperature alone, not by the body's shape or composition. That's based off the temperature. So, that really shouldn't be hard because I'll show you that. Temperature is a physical quantity that expresses hot and cold. It is the manifestation of thermal energy present in all matter, which is the source of occurrence of heat, a flow of energy. When a body is in contact with another, that it is colder or hotter. Yeah, but we already know that a living body, the temperature can be in between, like, I think it's like maybe 92 to maybe like 100 degrees Fahrenheit. Around in there. Let's just say, not to be exact, in between 90 and 100 is the temperature of a living human body. So, alright. An ideal black body in thermal equilibrium has two notable properties. One, it is an ideal emitter at every frequency. It emits as much or more thermal radiative energy as any other body at the same temperature. Two, it is a diffuse emitter measured per unit area, perpendicular to the direction. Okay. The energy is radiated isotropically. So isotropic radiator is a theoretical point source of electromagnetic or sound waves, which radiates the same intensity of radiation in all directions. It has no preferred direction of radiation. It radiates uniformly in all directions over a sphere centered on the source. Okay. Independent of direction. Gotcha. As the temperature of a black body increases, its intensity also decreases, and its peak moves to a longer wavelengths. Okay? So, an approximate realization of black surface is a hole in the wall of a large insulated enclosure. An oven, for example, right? You know what an oven is, right? For oven example, right? Any light entering the hole is reflected or absorbed at the internal surfaces of the body and is unlikely to remerge, making the hole a nearly perfect absorber. When the radiation confined in such an enclosure is in thermal equilibrium, the radiation emitted from the whole will be as great as from any body at that equilibrium temperature. Man, heavy stuff. Heavy stuff. Real materials emit energy at a fraction called the emissivity. The emissivity of the surface of a material is its effectiveness in emitting energy as thermal radiation. Thermal radiation is electromagnetic radiation that may include both visible radiation light and infrared radiation, which is not visible to human eyes. The thermal radiation from very hot objects is easily right of black body energy levels. By definition, a black body in thermal equilibrium has an emissivity E equals 1.A. Source. It's this source right here. As the temperature of a black body decreases, its intensity also decreases and its peak moves to longer wavelengths. Shown for comparison is the classical Rayleigh-Jeans law. The Rayleigh-Jeans law. In physics, the Rayleigh-Jeans law is an approximation to the spectral radiance of electromagnetic radiation as a function of wavelengths from a black body at a given temperature through classical arguments for wavelength. Gotcha. Ultraviolet catastrophe. The ultraviolet catastrophe, also called the Rayleigh-Jeans catastrophe, was the prediction of late 19th century, early 20th century classical physics that an ideal black body at thermal equilibrium will emit radiation in all frequency ranges. Okay. Okay. So, y'all already know. We're talking about spiritual growth. Talking about spiritual growth. And currently we're talking about the black body. Okay. So we're gonna get this. So this might just be, this will be part one. Yeah, this will be part one. This is gonna be long. This is gonna be long. So yeah. Alright. Okay. We're gonna start here because we need all this. We're gonna get all this. Right? Any light entering the hole is reflecting or absorbed at the internal surfaces of the body and is unlikely to re-emerge, making the whole a nearly perfect absorber. When the radiation confined in such an enclosure is in thermal equilibrium, the radiation emitted from the whole will be as great as from any body at the equilibrium temperature. Real materials emit energy at a fraction, called the emissivity of black body energy levels. By definition, a black body in thermal equilibrium has an emissivity E equals 1.8 source, with a lower emissivity independent of frequency. It is often referred to as a gray body. Constructing black bodies with an emissivity as close to 1 as possible remains a topic of current interest. In astronomy, right? Astronomy is a natural science that studies celestial objects and phenomena. It uses mathematics, physics, and chemistry in order to explain their origin and evolution. Objects of interest include planets, moons, stars, nebula, galaxies, and comets. That's astronomy. Right? So what is astronomy? Astronomy is a natural science that studies celestial objects and phenomena. Alright? Say it again. What is astronomy? Astronomy is a natural source that studies celestial objects and phenomena. Let's get it. The radiation from stars and planets. The radiation from stars and planets. What's a star? A star is an astronomical object consisting of a luminous spheroid of plasma held together by its own gravity. You hear me? So it's plasma, right? It's plasma, right? Plasma is not solid. Plasma is just like particles of something, right? Right? Held together by its own gravity. It looks like a solid. It could possibly be a solid or matter, right? But it's not. It's luminous spheroid, right, of plasma that's held together by its own gravity. The nearest star to Earth is the Sun. Many other stars are visible to the naked eye at night, but due to their immense distance from Earth, they appear as fixed points of light in the sky. Just dropped a bombshell. I hope somebody was listening. So, planets. A planet is an astronomical body orbiting a star or stellar remnant that is massive enough to be rounded by its own gravity. It is not massive enough to cause thermonuclear fusion, and according to the International Astronomical Union, but not all planetary sciences. Man, it made me want to go into that. Let's go on. If I open up any more tabs, man. Look, that's not it. We talking about something else. Alright, we're talking about spiritual awakening, right? Trying to figure out what it takes to have this spiritual growth, right? We're looking for spiritual growth, right? So right now we're talking about Blackbody. What is Blackbody? Blackbody is an idolized physical body that absorbs all incident electromagnetic radiation regardless of frequency or angle of incidence. Right? The name Blackbody is given because it absorbs all colors of light. A black body also emits black body radiation. In contrast, a white body is one of the tough is one with a tough surface that reflects all incident rays completely and uniformly in all directions. They dropping bombs. I don't get into this. Hopefully you take it how I take it. You take it how you take it. I take it how I take it. Alright. So let's go down here. I'm gonna read some more about this. Right. So this is their definition. The idea of a black body originally was introduced by Gustav Kirchhoff in 1860s as follows. Man, give me a break, Doug. These guys, man. I mean, I ain't trying to talk bad about Gustav. Gustav cool with me, but he needs to talk about where the original source. Give me one sec. Sorry about that. Been recording for an hour, so I had to take a quick emission. Quick intermission. Quick intermission. Okay. So let's get to the definition again. Mr. Gustav Kirchhoff says in 1860, as follows. The, what is this? Supposition, the supposition that bodies can be imagined which for infinitely small thicknesses completely absorb all incident rays and neither reflect nor transmit any. I shall call such bodies perfectly black, or more briefly, black bodies. Does this have anything to do with melanin? Melanin will be on another video. I want to touch melanin also. Listen, my page is all about spiritual awakening. We don't care about no color, meaning these race wars that we are currently going through is ridiculous. These definitions of black, white, brown, purple, green, which they really don't mean nothing. Those colors don't mean nothing, man. We're taking it back to the essence. The essence, man. I'm not trying to belittle nobody. I'm not trying to make nobody feel bad. Fair use. Educational purposes only. This is fair use. Educational purposes only. Fair use. Alright. A more modern definition drops the reference to infinitely small thicknesses. The notion of an infinitely thin layer was dropped by Planck. So this must be one. Just looking at some things, I'm sorry. An ideal body is now defined called a black body. A black body allows all incident radiation to pass into it. No reflecting energy and internally absorbed all the incident radiation. No energy transmitted through the body. This is true for radiation of all wavelengths and for all angles of incidence. Hence, the black body is a perfect absorber for all incident radiation. Yeah, I bet. Radiation is, you know what? Let's look up. I'm sorry. Radiation. What's the definition of radiation? So we could be clear on what radiation is. Radiation, the emission of energy as electromagnetic waves, you know what electromagnetic waves are, or as moving subatomic particles, especially high energy particles, which cause ionization. Right? Difference out from a central point in particular evolution from an ancestral animal or plant group into a variety of new forms. Evolution is a process of radiation, not progression. Radiation is an energy that comes from a source and travels through space and may be able to penetrate various materials. Light, radio, and microwaves are types of radiation that are called non-ionizing. The kind of radiation discussed in this document is called ionizing radiation because it can produce charged particles in matter. What is radiation? You already know. No. Waves of particles propagated through space or through a medium carrying energy. So check out the diagram. Okay. So let's go back to Blackbody. Cavity with a hole. Cavity with a hole. A widely used model of black surface is a small hole in a cavity with walls that are oblique to radiation. Radiation incident on the hole will pass into the cavity and is very unlikely to be re-emitted if the cavity is large. The hole is not quite a perfect black surface in particular. In the wavelength of the incident radiation is greater than the diameter of the hole. Part will be reflected. Similarly, even in a perfect thermal equilibrium.
You stay here tomorrow? You stay here tomorrow?
Yeah.
Okay.
Yeah. The radiation inside a infinite-sized cavity will not have an ideal Planck spectrum for wavelength comparable to or larger than the size of cavity. An approximate radiation of the black body as a tiny hole in an insulated enclosure. Right. Okay. Okay. Suppose the cavity is held at a fixed temperature, T, and the radiation trapped inside of the enclosure is a thermal equilibrium. Thermal equilibrium. Two physical systems are in thermal equilibrium if there is no net flow of thermal energy between them when they are connected by a path permeable to heat. Thermal equilibrium obeys the zeroth law of thermodynamics. Okay. The hole in the enclosure will allow some radiation to escape if the hole is small. The radiation passing in and out of the hole has negligible effect if the equilibrium of the radiation inside the cavity. This escaping radiation will approximate black body radiation. Remember black body radiation, right? So what's black body radiation? Let's go over it again. So black body radiation is the thermal electromagnetic radiation with or surrounding a body in thermodynamic equilibrium with its environment emitted by a black body that exhibits a distribution in energy characteristic of the temperature and does not depend upon the properties of the cavity or the hole, at least for wavelengths smaller than the size of the hole. See the figure of introduction for the spectrum as a function of the frequency of the radiation. So what is frequency? Because it said no matter the frequency. So the power spectrum of a time series described the distribution of power into frequency components comprising that signal. According to Fourier's analysis, any physical signal can be decomposed into a number of discrete frequencies or a spectrum of frequencies over a continuous range. It's all coming clear now. Which is related to the energy of the radiation by the equation E equals HF, with E energy equaling H, Planck's constant frequency. Right? So Planck constant, or Planck's constant, is a fundamental physical constant denoted, denoted, and is of fundamental importance in quantum mechanics. A photon's energy is equal to its frequency multiplied by the Planck constant due to mass energy equivalence. Okay. At any time, the radiation in the cavity may not be thermal equilibrium, but the second law of thermodynamics, which is the law of thermodynamics, define a group of physical quantities such as temperature, energy, and entropy that characterize thermodynamic systems in thermodynamic equilibrium. The laws also use various parameters for thermodynamic processes, such as thermodynamic work and heat. Right? So states that if left undisturbed, it will eventually reach equilibrium, although the time it takes to do may so be very long. Typically, equilibrium is reached by continual absorption and emission of radiation by material in the cavity of its walls. Radiation entering the cavity will be thermalized. In classic statistic mechanics, the H thorium, introduced by Ludwig Boltzmann in 1872, describes the tendency to decrease in quantity H in a nearly ideal gas of molecules, as this quantity H was meant to represent the entropy of thermodynamics. By this mechanism, the energy will be redistributed until the ensemble of photons achieves a Planck distribution. So again, Planck's law describes the spectral density of electromagnetic radiation emitted by a black body in thermal equilibrium at a given temperature T, when there is no net flow of matter or energy between the body and its environment. The time taken for thermalization is much faster with condensed matter present than with rarefied matter such as a dilute gas at temperatures below billions of Kelvin. Direct photon interactions are usually negligible compared to interactions with matter. Photons are an example of an interacting Boson gas. So, in quantum physics, a boson is a particle that follows Bose-Einstein statistics and was discovered by Satyendra Nath Bose. Bosons make up one of two classes of elementary particles, the other being fermions. The name boson was coined by Paul Dirac. Okay. And a description by the H theorem. Under very general conditions, any interacting boson gas will approach thermal equilibrium. Alright? So, you guys already know, we're talking about spiritual growth, starting with black bodies. Alright? So, I wanted to see something. I wanted to see if they had a video on this. Let's see. 1 second. Let's see. Right? Let's just see if we can find it. We're going to dismount here in a minute. I'm just trying to figure this out. So we're talking about black bodies. We're talking about black body. Let's see if we can find it. Black body. Ah, there it is. Black body. Radiation physics. Black body radiation. Alright, so this is the same one I just read. Let's see.
So let's say you have to read an incredibly long email from your boss that you have to finish before the big meeting starts in 10 minutes. You're cramming exam.
You've certainly seen infrared goggles before, and maybe you've seen this scene in Predator, where Arnold covers enough blood to mask the body heat and the light gives off. But why is Arnold's body normally glistening in infrared? What causes this phenomenon? we discuss some phenomena, we almost always wind up somewhere in the quantum world. Because if you ask why enough times, eventually that's where you wind up. So it should come as no surprise that there's a bit of a quantum element to describe blackbody radiation. Luckily, we won't be sitting around here for too long. The first thing to tackle is to figure out what exactly is heat. I'm sure you've heard that heat is the kinetic energy of molecules or atoms within matter, and that's 80% of the story. But if we want to be a little more precise, we can say that heat is the excess energy that a molecule or atom contains above its ground state. This can be presented visually as changes in rotation, location, and vibration. These are all manifestations of excess energy. When we supply heat to something, we're simply forcing molecules to undergo one of these changes. Friction is the interaction of the electrons between two surfaces repelling each other, thus moving them apart. This movement creates momentum, changes in kinetic energy, and subsequently heat. Now, we have to enter the quantum world. The electron and the electromagnetic field have a very intimate relationship. Because the electromagnetic field is a manifestation of charges, and the electron has a charge or its own magnetic field, changes in one directly influence the other. They're very much like a boat in water. The boat can't go anywhere without creating waves or ripples, and the more aggressive the boat moves, the larger the waves. Similarly, the boat can be influenced by waves as well. Therefore, whenever an electron changes its own magnetic field, either by changing its momentum or wave function, it sends ripples or photons through the electromagnetic field. That is to say, a change in energy of an electron will always produce a photon. As we leave the quantum world, we keep this little factoid in mind. Changes in electron energy produce light. Blackbody radiation is ultimately the phenomenon we want to discuss today. And having learned that changes in electron energy levels produce light, we could hypothesize that maybe really hot objects glow because the electrons inside are changing their energy a lot. Let's see how that would work. If we visualize a simple model of an atom, we see an electron whizzing about the nucleus. It exists in an orbital. That orbital describes a wave function or energy state for our electron. As long as the electron is in that orbital, it has the same amount of energy. As one would imagine, it can certainly increase its energy by transferring into a new orbital, but not easily. An orbital describes a wave function, and waves are dictated by their boundaries. If we imagine a guitar string in a box and we wanted to change its wave function, we'd find unless the wave's nodes appear at the edge of the box, it will collapse. Therefore, only a handful of waves fit in this box. Our electron orbitals are the same. Only certain wave function will fit around that, and each orbital and subsequent wave function possess a unique energy level. So our bounded electron can only change its energy in quantized amounts, and these changes in energy stimulate the creation of photons. But how does heat play into this? An opera singer singing at the right pitch can cause a wine glass to break. Molecules naturally vibrate with thermal energy. Like the breaking glass, if a molecule vibrates with the right frequency, those vibrations stimulate the excitation of an electron to a higher orbital. As the electron returns back to its ground state, it produces light. A vibrating molecule doesn't always vibrate with the right frequency to excite one of its electrons. But a vibrating molecule can vibrate against their neighbor and transfer some of their internal energy to them. This new excess of energy that is transferred can create faster vibrations, which in turn can then excite an electron. As we increase the temperature, more and more vibrations cause more and more excitation of electrons. Stronger vibrations also cause electrons to jump into even higher orbitals. Since electrons in higher orbitals possess even greater energy, when they return to their ground state, they emit even more energy. If we can excite an electron into a high enough orbital, at some point, the light energy it gives off when it returns to its ground state will be in the visible spectrum. In matter, orbitals of nearby molecules and atoms overlap and create even more orbitals, or nooks and crannies electrons can occupy. So even though each orbital requires a specific amount of energy, so many of them that electrons can release a large variety of light as they transition around. So many that the light appears white to us if the object gets hot enough. That's the basic mechanism for most Blackbody radiation in the visual spectrum. But there are a few more sources. Since the electromagnetic field is just that, a field, it has an orientation of where it wants things to be pointed, exactly like a magnet. In most places in the universe, the forces of the electromagnetic field are incredibly weak, but they exist. A lot of molecules are what we call polar. That means there exist charges at all times within its geometry. We'll visualize water for this. Water has very distinct positive and negatively charged poles. This means it's kind of like a magnet and has a magnetic field that looks like this. If the universe had its way, it would prefer for this field to align with its own. So there is a force that wants the water molecule to align a certain way. In order for the water molecule to rotate, it needs to act against that force. It needs external energy. So if we give it energy in the form of heat, it may rotate. And this rotation is a change in the electromagnetic field that causes a photon to create a mediate change. Since these forces are so weak, the energy of the photon is very insignificant as well. Therefore, anytime a polar molecule even ever so slightly changes its orientation in space, it produces a photon. But these photons are extremely unimpressive, and as far as we're concerned, contribute very little to what we observe as blackbody radiation. The other main source of light in blackbody radiation is from free electrons. When things get incredibly and stupidly hot, like in plasma, electrons realize there's really no reason for them to be sticking around this hot mess and detach completely from their respective molecules. When an electron isn't bound to an atom or molecule, they're called free electrons. Free electrons can carry much or as little energy as they want. When bound to an atom, they only absorb a specific quanta of energy. As a free electron, they can absorb whatever they want. Free electrons fly about bumping into each other in ions. These collisions greatly reduce their kinetic energy, or changes their influence on the electromagnetic field. This produces Bremsstrahlung, which is German for breaking radiation. This isn't that common on Earth because most of our electrons have a home. But some of the light from lightning is due to this process. Lastly, we should be asking, why is it called blackbody radiation? This is simply an assigned to a theoretical material that could absorb every single wavelength. In reality, all materials either reflect or let some wavelengths pass directly through them. Since we associate the color black with the absorption of visible light, we call a material that could theoretically absorb all light back as well. So when we measure the radiation from an object, some of it is reflected and transmitted. But blackbody radiation is the radiation that comes specifically from the object itself. Therefore, when we heat an object up, more and more of that observed radiation comes from the object itself. And that is blackbody radiation.
We have a clear understanding of my hijacks. Let me okay, clear understanding of Blackbody. A small little quick video real quick. And I'm about to dismount and read the rest of this, and we're gonna get out of here and prepare for what was that? Blackbody radiation. So right now we're talking about Blackbody and spiritual growth. Alright. So, okay, here we go. Transmission, absorption, and reflection. A body's behavior with regard to thermal radiation is characterized by its transmission, absorption, and reflection. The boundary of a body forms an interface with its surroundings, and this interface may be rough or smooth. A non-reflecting interface separating regions with different refractive indices must be rough because the laws of reflection and refraction governed by the Fresnel equations. For a smooth interface requires a reflected ray when the effractive indices of all the material and its surroundings differ. A few idealized types of behavior are given particle names. An opaque body is one that transmits none of the radiation that reaches it, although some may be reflected. Here's the problem. A transparent body is one that transmits all the radiation that reaches it. That is the mathematical equation for that. A gray body is one where this A, P, and T are constant for all wavelengths. This term also is used to mean a body for which A is temperature and wavelength independent. The white body is one for which all incident radiation is reflected uniformly in all directions. For a black body, Planck offers a theoretical model for perfectly black bodies, which he noted do not exist in nature. Besides their opaque interior, they have interfaces that are perfectly transmitting and non-reflective. This is Kirchhoff's perfect black bodies. Kirchhoff, in 1860, introduces the theoretical concept of a perfect black body with a completely absorbing surface layer or infinitely small thickness. But Planck noted some severe restrictions upon this idea. Planck noted three requirements upon a black body. The body must allow radiation to enter but not reflect, possesses a minimal thickness adequate to absorb the incident radiation and prevent its re-emission, satisfies severe limitations upon scattering to prevent radiation from entering and bouncing back out. As a consequence, Kirchhoff's perfect black bodies that absorb all radiation that falls on them cannot be realized in an infinitely thin surface layer and impose conditions upon scattering of the light within the black body that are difficult to satisfy. Realizations. A realization of a black body refers to a real world physical embodiment. Here are a few. Cavity with a hole. In 1898, Autumn Loomer and Ferdinand Carbon published an account of their cavity radiation source. Their design has been used largely unchanged by radiation requirements to the present day. It was a hole in the wall of a platinum box divided by diaphragms, with its interior blackened with iron oxide. It was an important ingredient for the progressively improved measurements that led to the discovery of Planck's law. A version described in 1901 had its interior blackened with a mixture of chromium, nickel, and cobalt oxides. Near black materials, there is interest in black body-like materials for camouflage and radar absorbent materials for radar invisibility. They also have application as solar energy collectors and infrared thermal detectors. As a perfect emitter of radiation, a hot material with black body behavior would create an efficient infrared heater, particularly in space or in a vacuum where convective heating is unavailable. They are also useful in telescopes and cameras as anti-reflection surfaces to reduce stray light and to gather information about objects in high contrast areas. For example, observation of planets in orbit around their stars, where black body-like materials absorb light that comes from the wrong sources. It has long been known that a lamp black coating will make a body nearly black. An improvement on lamp black is found in manufactured carbon nanotubes. Carbon nanotubes. Carbon nanotubes, CNTs, are tubes made of carbon with diameters typically measured in nanometers. Okay. Nanoporous materials can achieve refractive indices, nearly that of vacuum, in one case obtaining average reflectance of 0.045%. In 2009, a team of Japanese scientists created a material called nano black, which is close to an ideal black body, based on vertically aligned single-walled carbon nanotubes. This absorbs between 98% and 99% of the incoming light in a spectral range from the ultraviolet to the far infrared regions. Other examples of nearly perfect black materials are super black. Super black is a surface treatment developed at a national physical laboratory in the United Kingdom. It absorbs approximately 99.6% of visible light at normal incidence, while conventional black paint absorbs about 97.5% of other angles of incidence. Super black is even more effective at an angle. Prepared by chemically etching a nickel phosphorus alloy, vertically aligned carbon nanotube arrays like Vanta Black. Vanta Black. Manta black is a brand name for a class of super black coatings with total hemispherical reflectivenesses below 1.5% in the visible spectrum. The original plant Vanta black coating was grown from a chemical vapor deposition process developed by Survey Nanosystems in the United Kingdom. Man. And fluorocarbon nanostructures all absorb 99.9% of light or more. Ooh. Alright, for the dismount, we're going to read stars and planets. And we're going to read let's get black holes, and we're going to read black holes, right, and cosmic microwave background radiation. Alright, so black holes. A black hole is a region of space-time from which nothing escapes. So space-time in physics, right? In physics, space-time is any mathematical model which uses the three dimensions of space and the one dimension of time into a single four-dimensional manifold. Space-time diagrams can be used to visualize, what is this, relativistic effects. Space-time. Okay. For which nothing escapes. Around a black hole, there is a mathematically defined surface called an event horizon. In astrophysics, an event horizon is a boundary beyond which events cannot affect an observer. That marks the point of no return. It is called black because it absorbs all the light that hits the horizon, reflecting nothing, making it almost an ideal black body. Radiation with the wavelengths equal to or larger than the diameter of the hole may not be absorbed. So black holes are not perfect black bodies. Physics believe that to an outside observer, black holes have a non-zero temperature and emit black body radiation. Radiation with a nearly perfect black body spectrum ultimately evaporating. The black hole is a region of space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light can escape from it. The theory of general relativity predicts that a sufficiently compact mass can deform space-time to form a black hole. Okay. The mechanism for this emission is related to the vacuum fluctuation. The quantum physics. A quantum fluctuation is the temporary random charge in the amount of energy in a point in space as prescribed by Werner Heisenberg's uncertainty principle. They are tiny random fluctuations in the values of fields which represent elementary particles, in which a virtual pair of particles is separated by the gravity of the whole, one member being sucked into the whole and the other being emitted. The energy distribution of emission is described by Boris Blacks with a temperature T. Okay. Okay. Where C is the speed of light, is the reduced Planck constant, is the gravitational constant, and M is the mass of the black hole. These predictions have not yet been tested either observationally or experimentally. Cosmic microwave background radiation. See also Big Bang. And cosmic microwave background radiation. Cosmic microwave background in Big Bang cosmology is electromagnetic radiation, which is a remnant from an early stage of the universe, also known as relic radiation. The CMB is faint cosmic background radiation filling all space. It is an important source of data on the early universe. The Big Bang Theory is based upon the cosmological principle, which states that on large scales the universe is homogeneous and isotropic. According to theory, the universe, approximately a second after its formation, was a near ideal black body in thermal equilibrium at a temperature above 10. The temperature decreased as the universe expanded and the matter and radiation in it cooled. The universe expanded. Okay. The cosmic microwave background radiation observed today is the most perfect black body ever measured in nature. It has a nearly ideal Planck spectrum at a temperature of about 2.7. It departs from the perfect isotropy of true black body radiation by an observed anisotropy that varies with angle on the sky only to about 1 part in 100,000. Yeah, man. So we're going to go ahead on here and dismount. And we're going to pick up at radiative cooling. Pick up right here. So we've been talking about spiritual growth. starting with Blackbody. Peace.